Now we're going to apply a test to determine if f and g are inverses of each other. Looking up in this box here, if you go f composite g of x or g composite f of x and both return x, then they are inverses of each other. So here we go. We have two functions, w and z, and we want to determine by this definition whether they are inverses of each other. So we are going to try w composite z of x. That basically means function z is going to get substituted into the w. The one closest to the of x gets substituted into the one that's further away from the of x. Function w says take 6 over input plus 2. And the input is function z here, which will be 6 minus 2x over x. Okay, now we need to simplify this expression. The numerator is going to stay 6. Down below, we're going to have 6 minus 2x over x plus 2x over x, multiplying the 2 by x over x so we can have this common denominator. When we combine these together, we get 6 all over, I'm going to slide this to the right a little bit so you can see it, 6 minus 2x plus 2x all over x. And you can see that the minus 2x and the plus 2x cancel each other out. So we now have, moving to the next line, 6 divided by 6 over x. Now when you divide with fractions, you multiply by the reciprocal. So we're going to have 6 times x over 6, which is going to equal x. Now that's what we were looking for. Now we need to determine if we get the same result when we take z composite w of x. This time the w is going to get substituted into the z, and z is the function 6 minus 2 input all over input. Okay, now let's substitute function w in. We're going to substitute in the 6 over x plus 2 in both instances and then simplify. We now have upstairs 6 minus, now this is really a 2 over 1, so we're going to have 12 over x plus 2. And down below it's just going to stay 6 over x plus 2. Now I'm going to simplify this complex fraction by multiplying by x plus 2 over x plus 2. This is really 1 in a special form, and I'm going to think of that as x plus 2 over 1 and x plus 2 over 1. And we're going to distribute that through both in the numerator and the denominator. So let's see what we've got. On the next line, we will write, okay, we're going to have 6 times x plus 2, then minus the 12 after these x plus 2's cancel each other out. Then down below, this will be over 6 because the x plus 2's will cancel each other out. We now have 6x plus 12 minus 12 over 6. The 12's are going to cancel each other out, leaving 6x over 6. But then the 6's are going to cancel each other out also, and that will leave us with x. Now this is not the type of proof that you're used to looking at, but because w composite z turned out to equal x, and z composite w turned out also to equal x, that tells us that functions w and z are inverses of each other. So I guess the answer would be yes to this problem. Yes, they are inverses.